Welcome to Balaya Math Lectures. Learn every step. Today we are going to discuss elementary operations. First of all, let us learn elementary row operations. In the similar fashion, we can get through elementary column operations. The first elementary row operation is interchange of two rows. That means ith row can be replaced with jth row and jth row will be replaced with ith row. That is denoted by Ri if and only if Rj. Let me show here. Ri if and only if Rj. For example, you can get clarification by taking an example. If you take a matrix A as 2, 1, minus 2, 3, 2, 1, 1, 2, minus 2. Now, I wish to interchange first row and third row. This could be noted as R1 if and only if R3. This means all the elements of first row will be replaced in third row and all the elements of third row will be replaced in first row. So this is equivalent to the matrix 1, 2, minus 2. There is no change in the second row because we do not apply any operation on second row, so that 3, 2, 1. Now 2, 1, minus 2 should be replaced in third row according to our elementary row operation. Now coming to next elementary row operation. You can multiply with a non-zero scalar to any row. This could be denoted as Ri tends to k into Ri. That means ith row can be multiplied with a non-zero scalar k and the resulting value should be noted in the ith row itself. That means for the same example, let us multiply first row with 2. Not only first row, you can any row, you can multiply with any row. Operation can be noted as R1 tends to 2 into R1. This is equivalent to 2, 4, minus 4. As I am considering the same example and I am taking this matrix. That's why I am multiplying R1 with 2. That means each and every element of first row will be multiplied with 2. So there is no change in the rest of the rows. That means 3, 2, 1, 2, 1, minus 2. Now coming to the third elementary row operation, you can multiply any row with a non-zero scalar and add it to the corresponding elements of any another row. That means suppose Ri tends to Ri plus k into Rj. This means jth row can be multiplied with a non-zero scalar k and multiply the resulting values to corresponding elements of ith row, and the resulting value should be noted in ith row itself. If suppose I am multiplying this one with 2 and this one with 3 and subtract from them, that means this operation can be noted as R3 tends to 3 into R3 minus 2 into R2. I am multiplying third row with 3 and second row with 2 and I am subtracting from them. I am subtracting these two values. That means the resulting will be no change in the first row 2, 4, 4 and no change in the second row 3, 2, 1 and 3 into R3, 3 2s are 6 and 2 3s are 6. 6 minus 6, 0 and 3 into 1, 3, 2 2s are 4, 3 minus 4, minus 2 into 3, minus 6, minus 2, minus 8. This is the resulting matrix. These are called elementary row operations. Now, by replacing R with C, you can learn elementary column operations. That means for the same operation, Ci if and only if Cj. That means any ith column can be replaced with jth column, and jth column will be replaced with ith column. This is interchanging of any two columns. If suppose I am writing C2 if and only if C3, these elements will be replaced in C2 and these elements will be replaced in C3. This is your elementary column operation. Now coming to this operation, Ci tends to some k into Ci. Ith column will be multiplied with a non-zero scalar k and the resulting values will be noted in the ith column. So this is denoted as Ci tends to k into Ci. Now coming to the last elementary column operation, Ci tends to Ci plus k into Cj. That means jth column will be multiplied with a non-zero scalar k and add them to the corresponding elements of ith column and the resulting value will be noted in the ith column itself. These are elementary column operations. I think you can get clarified on elementary row operations and elementary column operations. This is the lecture on elementary operations.